But tomorrow in your quiz, it's only section 1.8. You're going to have some solving and some inequalities. And maybe 3 and 3, something like that, I think. But you have to check, guys. You have to check the solving ones for extraneous solutions, and you have to check inequalities to see if it's no solution or all reals. So it's really important to take the time to check. You don't have to do a long formal check like I did on the review answers. I just worked it all out so you guys could see. But I'll show you how you can go through and just kind of check it in your head as you go through, just to make sure that they work, okay? So let's look at number 1. Any of the solving questions, you want to remember you're going to isolate the absolute value. That's what you're trying to do first. Then you can go ahead and split it up and solve. So the first thing we're going to do here is subtract 7 from both sides. So you have negative absolute value of 2x minus 5 equals negative 34. Divide both sides by a negative 1. And you have the absolute value of 2x minus 5 equals positive 34. Once you get the absolute value by itself, that is when you now can split it up into 2 and solve. So you have 2x minus 5 equals 34. And you have 2x minus 5 equals negative 34. With absolute value equations, all you do is just change the sign. And in inequalities, when you change the sign of the answer and flip the inequality sign. So we're going to go through and we're going to add 5 to both sides. We get 2x equals 39. Divide both sides by 2. And you get x equals 39 over 2. Same thing, we're going to add 5 over here. Be careful with your signs. 2x equals negative 29. Divide by 2, and you get x equals negative 29 over 2. Now, we need to go back and check. You guys can do the check in your head. I am not looking, I'm not going to mark off if you don't, but you need to be careful because not everything is going to work all the time. When I plug in 39 over 2 here, watch, if I say 39 over 2, you guys agree with me, these 2's would cancel out. So then, in your mind, guys, 39 minus 5, 34. What's the absolute value of 34? So you have 7 minus 34. Does that give you negative 27? Yeah, so you're good. So now do the same thing, and we're going to plug in negative 29 over 2. 2's cancel out. What's negative 29 minus 5? Negative 34. What's the absolute value of negative 34? 34. So 7 minus 34, negative 27. So both of these work. You're good to go. Questions? All right, moving along to number 2. Excuse me. Again, we want to isolate your absolute value. What do I have to do to get the absolute value all by itself? Divide by 2. Just divide both sides by 2. So the absolute value of 5x minus 1 equals 2. Now that your absolute value is by itself, we can split it up. 5x minus 1 equals 2. 5x minus 1 equals negative 2. So on the left-hand side, I'm going to add 1. 5x equals 3. Divide by 5. And x equals 3/5. Over here on the right, I'm going to do the same thing. I'm going to add 1. So 5x equals negative 1. Divide by 5. And x equals negative 1/5. All right, quick little check, guys. If I plug in 3/5 here, 3 over 5, your 5's cancel, right? So 3 minus 1 is 2. The absolute value of 2 is, and 2 times 2 is 4. So that one works. All right, so now let's do 1/5. Negative 1/5, sorry. Negative 1/5 here. The 5's will cancel. What's negative 1 minus 1? Negative 2. What's the absolute value of negative 2? Positive 2. And then 2 times 2 is 4. So that works. All right? If you want to do a big, long, formal check, you're more than welcome to. I'm just telling you guys don't have to, but you do absolutely need to check the answers. Sure. All right, scooting down to number 3. Again, we're going to isolate. So we're going to add 5 to both sides. Absolute value of 3x plus 4 equals 8. Now that the absolute value is completely by itself, we can split it up. 3x plus 4 equals positive 8. 3x plus 4 equals negative 8. Whoops, that looks weird. So we'll subtract 4 from both sides. 3x equals 4. Divide both sides by 3, and x equals 4/3. Same thing on the right. We're going to subtract 4. So 3x equals negative 12. Divide by 3, and x equals what? Negative 4. All right, take 2 seconds to go back up and look. If I plug in 4/3 here, 4 over 3, the 3's will cancel. What's 4 plus 4? 8. Absolute value of 8 is 8. 8 minus 5 is 3. You're good. Plug in negative 12 here. Sorry, negative 4. Negative 4 times 3 is negative 12, right? Negative 12 plus 4 is negative 8. Absolute value of negative 8 is positive 8. 8 minus 5 is 3. So we're good. Doesn't have to be anything major. You just have to make sure things work out correctly. All right, come over here. Same thing. We're going to do the same thing. A lot of you had questions on this one last week when we started it. We're going to isolate. First thing I'm going to do is what? Okay, add 6. So negative 1/5 times the absolute value of x minus 16 equals 2. How do you get rid of multiplying by 1/5?
Multiply negative 5 to both sides.
You multiply by the reciprocal, 5 over 1. Now, you could do 5 over 1, and then you'd have to multiply or divide by negative 1. I would go ahead and get that out of the way. I would just multiply this side by 5 over 1, and this side by negative 5 over 1. So you have the absolute value of x minus 16 equals negative 10. Now that the absolute value is by itself, you can split it up. X minus 16 equals negative 10. X minus 16 equals positive 10. So go ahead, add 16 to both sides. I get x equals 6, right? I'm going to add 16 to both sides, and I get x equals 26. What should I do?
Plug it back in.
I should plug back in to check. If I go back up here to the original. Okay, if I plug in 6 right here, I got 6, the first one, right? What is 6 minus 16? Negative 10. Okay, what's the absolute value of negative 10? 10. What is negative 1/5 times 10? Negative 2 minus 6. Does that give me negative 4? No, so this one doesn't work. Okay, it looks like it should have, but it doesn't. You have to go back and check, guys. If I plug in 26, right? What's 26 minus 16? 10. What's 10 times negative 1/5? It's going to give me negative 2 again. What's negative 2 minus 6? It's not negative 4. So this doesn't work. So what's your answer here, guys? No solution. If you do all of that work and don't plug it back in, say this is worth 8 points, I'll give you 2. The main thing is that you understand that you have to check your answers because not everything is going to satisfy an absolute value equation. You've got to check your answers. Marcel? All right, when you come to something like number 5, this is not an extremely difficult problem. Yes, you have fractions, but you're going to have fractions. You guys need to be able to work with them. Okay, we're going to do the same thing. We want to isolate the absolute value. So I'm going to subtract 5 from both sides. So I get the absolute value of 2/3 x plus 1/2 equals 8. Now that the absolute value is by itself, go ahead and split it up. You have 2/3 x plus 1/2 equals positive 8. 2/3 x plus 1/2 equals negative 8. You're going to have to get a common denominator, guys. We should be getting better at this, but if I'm going to subtract 1/2 from both sides, all right, common denominator between 1 and 2 is going to be 2. So this is going to stay negative 1/2. What does 8 over 1 become? 16 over 2. Good. So this is 2/3 x equals 16 minus 1 is 15 over 2. When I get to this point, I'm really dividing, right? 15 over 2, then we're going to divide by 2/3. When you divide by a fraction, it's the same as multiplying by what? The reciprocal. So I can multiply this side by 3 over 2, and that'll cancel. And what you do to one side, you do to the other. So this becomes x equals 15 times 3 is 45. 2 times 2 is 4. We're going to do the exact same thing over here. We're going to have the same common denominator, all that. But notice, this is negative 1/2. This is negative 16 over 2. That negative stays with that 8. So you have 2/3 x equals negative 17 over 2. Multiply by the reciprocal, so 3 over 2, 3 over 2. And you get x equals negative 17 times 3 is negative 51 over 4. Now, some of you are like, I am not plugging that back in. You should check your work, guys. You need to plug back in and check to see if the solutions are correct or not. The way that you would plug this back in, you have 5 plus. So I have 2 over 3. This first one is 45 over 4, right? Plus 1/2. Does that equal 13? Well, this becomes a 1. This becomes a 2, right? So you have 5 plus 45 over 6. Can I change 1/2 to sixths? How would I change 2, the denominator of 2, to a 6? Multiply by 3. So I multiply the bottom by 3, then I multiply where? Top by 3. So this would be 3 over 6. What's 45 plus 3? 48 over 6. Good. Whoops, I forgot a plus sign. What is 48 divided by 6? 8. What is 5 plus 8? 13. When I plug negative 54 over 4, I get inside the absolute value negative 48 over 6, which becomes the absolute value of negative 8, which is positive, which works. Just because it's a fraction, guys, you need to check your work. Does anybody have any questions about the solving part? Solving equations. All right, now we're going to go to inequalities. There's a few more things you need to remember here. Same kind of process. Same kind of process, but, what'd you say, babe?
Why'd you make it a 1 over 3?
Where?
When you multiplied it by 45 over 4? It was a 2 over 3.
Because I can't, this was a 2 here, hold on. This was a 2, and this was a 4. So I said 2 goes into 2 one time, and then I said 2 goes into 4 2 times. I just simplified inside. Good question. Go ahead. All right, so first thing I would do here, right? I look at this inequality, and I read the inequality sign. What does that sign say?
Greater than or equal to.
It says or, right? Or equal to. So when we have an or and it's equal to, that means your dots are closed, and or means you're going in the opposite direction, all right? That will be true in your answer unless you multiply or divide within your problem to get absolute value by itself by a negative number. As soon as you multiply or divide by a negative when you're working through this, you have to flip. But if you don't, then that should stay true. So again, you have to isolate your absolute value. So I'm going to add 3 first. So I have 2 times the absolute value of 4x minus 1 greater than or equal to 12. Now what?
Divide by 2.
Okay, divide both sides by 2. So I have the absolute value of 4x. No, I don't know why I did that. Hang on. I was looking at that. I'm like, that's not what should happen. What should I do to both sides? Subtract 3. Silly me. Subtract 3. Okay, sorry. 4x minus 1. And then greater than or equal to 6, right? Still need to get absolute value by itself. When I divide by 2, am I dividing by a negative number? No, so my inequality sign stays just like it is. 6 divided by 2 is 3. Now that I have my inequality to where my absolute value is by itself on the left-hand side, now we can split. When you split your inequality, 4x minus 1 greater than or equal to 3. My other inequality says 4x minus 1 is less than or equal to -3. You change the sign of the answer and you flip the inequality sign. And now we just solve. I'm going to add 1 to both sides. So I have 4x greater than or equal to 4. Divide by 4 to get x is greater than or equal to 1. On the right-hand side, again, we're going to add 1. So 4x is less than or equal to -2. Divide by 4, and x is less than or equal to -1/2. Your answer for your inequality is your graph and your interval notation. Some of you on your last test just didn't even do the interval notations. That's a big part of the points. If I'm going to graph this, I need to see -1/2 on your number line. I need to see the 1, and I need to see 0, so you understand where the numbers are in relationship to 0. What kind of dots, according to what I said at the very beginning? What kind of, okay, closed. And which way should I color? What did I say at the beginning? Outside. We're going the opposite directions. Now, this is where you need to check. You should check graphically, meaning looking at your inequality signs, and you should check algebraically. You should plug in a number or two. The way that my inequality signs are written, it says x is greater than, so it means I should color which way? Which way should I color from 1? To the right, which is what I did. Over here, which way should I color from -1/2? To the left, which is what I did, right? So let's check algebraically. Let's plug in 0. If I plug in 0 into this inequality, should it work? No, because I didn't color. So if I plug in 0 right here, if the absolute value of -1 is 1, right? 1 times 2 is 2, and 2 plus 3 is 5. Is 5 greater than or equal to 9? No, so that means I have this done correctly. So how would you write your interval notation? From left to right. -infinity to -1/2, good. Bracket, good. Union, 1 to infinity. Somebody last period said, how do you know when to use the U? Guys, if there is a space, put a U there. It'll remind yourself, ooh, I have a union. If you ever have an or where you're going in opposite directions, that's where you'll have your U. That is the answer that I'm looking for inequalities. Questions? All right, let's look at the next one. I'm going to go through all these, so make sure we don't have any questions. First thing I like to do is say, okay, what does my inequality sign say? And. Okay, good. When I have an and, do I color in the middle or in the outsides? Middle. And what kind of dots do I have here? They're both open. Good. Because it's not or equal to. So let's get this absolute value by itself. What do I do first? Add 4. So I have 8 times the absolute value of x minus 1 less than 6. Now what? Divide by 8. Absolute value of x minus 1 is less than what? 3 over 4. Now that my absolute value is by itself, we can split it up. X minus 1 less than 3 over 4. X minus 1 greater than what? Negative 3 over 4. You flip the inequality sign and you change the sign of the answer. So guys, we got to get a common denominator again. But look, if I add 1, if I change 1 into fourths, what does that become? 4 over 4. Good. So x is less than 7/4. So I'm going to add 1 again. What was 1 in fourths? 4 over 4. So this becomes x is greater than 1/4. So on a number line, I have 0, 1/4, 7/4. What kind of dots do I have at 1/4 and 7/4? Open. And where did you originally say we should color? In the middle, okay? So let's check. From 7/4, which way should I have shaded? To the left. Is that what we did? Yes. From 1/4, which way should we have shaded? To the right. Is that what we did? Yes. Another way that you can check is to plug in 0. If I plug in 0, should it work? No. I didn't color there. So when I plug in 0 here, I get absolute value of negative 1 is 1 times 8. 8. 8 minus 4 is 4. Is 4 less than 2? No. So we're right. So my interval notation here would be 1/4 to 7/4, and it's in parentheses because it's not included. It's in parentheses because it is not included. Questions? All right, moving along. I have 3 more to do. I changed the last 2 just because I wanted a specific kind of question and answer. But guys, these last 3 are very important because they're a tad bit different from what we've been doing. Things change a little bit. When I first look at this problem, I look at the inequality sign and it tells me what? Does that say less than or equal to or greater than? Less than. Okay, this is an and. With an and problem, we color in the middle, right? And I'm going to close my circles because it says or equal to. But I have a denominator. How do you get rid of denominators? How do I get rid of that 2x, the absolute value of 2x minus 6 in the bottom? I'm going to multiply. I'm going to multiply both sides by the denominator. I'm going to multiply this side by 2x minus 6, absolute value, and this side by the absolute value of 2x minus 6. So this cancels. So I have 10 less than or equal to 5 times the absolute value of 2x minus 6. Now what? Divide both sides by 5. So I have 2 is less than or equal to absolute value of 2x minus 6. What's the problem with this? Why don't we like this? The x is on the right-hand side. We don't like when the x is on the right-hand side. Whenever you have the x on the right-hand side, I've told you guys, you want to switch it. You want to rewrite it. When I rewrite this as the absolute value of 2x minus 6, read it backwards. 2x minus 6 is what? Greater than or equal to what? 2. When you flip it, guys, when you read it out loud, 2x minus 6 is greater. This is no longer an and problem. It has become a what? An or. All right. Now, if you didn't catch that, you would catch it at the end if you go through and do your check. Because now that the absolute value is by itself, we can go ahead and split it up. 2x minus 6 greater than or equal to 2. 2x minus 6 less than or equal to negative 2. So we're going to add 6 to both sides. 2x is greater than or equal to 8. Divide by 2, and x is greater than or equal to 4. Same thing over here. I'm going to add 6 to both sides. 2x is less than or equal to 4. Divide by 2, and x is less than or equal to 2. So on my number line, I have 0, 2, and 4. You guys told me I had what kind of dots? Close. Good. Now, originally we said this was an and problem, and we would color in the middle. But then we realized that, oh, wait, it flipped. So but again, if you did not realize that, check your inequalities. Where is this inequality telling me I should color, from 4? What direction? To the right. Good. And then this inequality is telling me I should color which way? To the left. So sometimes when we flip and stuff in the middle, and our thought process of what you thought was going to happen changes, the way to check yourself is, okay, well, let me check 0. Because originally I thought I was going to color in the middle, but let me see, with the way that I colored, because that's what my inequality says, does 0 work? If I plug 0 in way back up here, I have 10 over the absolute value of negative 6 less than or equal to 5. Is 10 over 6 less than or equal to 5? How many times can 6 go into 10? 1 time, so it's definitely less than. So yes, this is correct. So sometimes if you don't catch, like, oh, I flipped here, I did something like that, you should be able to catch it at the end. So your interval notation here would be negative infinity to 2, bracket, there's a gap here, so I'd have union 4 to infinity. And this is my answer. You have to have brackets on your numbers because it's or equal to, and you have parentheses on your infinities. All right, the last two, guys, pay attention. I'm making some changes. You are going to change 14 to positive and 28 to negative. What does my inequality sign say? It says or, and I have or equal to, so I know they're going to be colored in, and I'm going in opposite directions. So if I want to get absolute value by itself, what do I have to do to both sides? Divide by 14. So absolute value 2x minus 7 greater than or equal to negative 2. You guys should be able to tell me right now what the answer is. Okay, this is why we're going to work through this. Your two choices are either going to be all real solutions or no solution. Just because you guys see negative, don't just go, oh, it's no solution. What that says is absolute value is greater than or equal to a negative number. When will that happen? Always. Always. Your absolute value will always be. But this is why I caution you not to just jump to, oh, this one's no solution or all real. You guys may have that on your quiz tomorrow. Some versions may not. So just, I would go ahead and go through the solving process. Is my absolute value by itself? Yes. Okay, so let's go ahead and 2x minus 7 greater than or equal to negative 2. 2x minus 7 less than or equal to positive 2. So add 7. 2x greater than or equal to 5. Divide by 2. X is greater than or equal to 5 over 2. Yeah? Okay, so then over here I'm going to add 7. 2x is less than or equal to 9. Divide by 2. X is less than or equal to 9 over 2. So let's graph it. 0, 5 over 2, 9 over 2. What kind of dots do I have? Closed. And where did we originally say we were going to color? On the outsides, okay? So outside, outside. So let's check our inequality signs. Where should I be coloring from 5 over 2? It's saying to the right. Okay. Where should I be coloring from 9 over 2? It's saying to the left. Do you guys see what your solution is? All of them. It's saying I can use everything. Again, if you're like, wait a second, I still don't think it's right. Plug in something to the left of 5 over 2. Plug in 0. If I plug in 0 here, right, 2 times 0 is 0. The absolute value of negative 7 is positive 7. If I multiply 7 by 14, I don't need to know what that value is, but I do understand that it's bigger than what? A negative number, correct? So then anything over here is going to work. If I plug in a number between 5 over 2 and 9 over 2, say 4, right? So 2 times 4 is 8. 8 minus 7 is 1. Is 14 bigger than negative 28? Yeah. Plug in something bigger than 9 over 2, say 10. What's 2 times 10? 20 minus 7, 13. 13 times 14, that's bigger than negative 28, right? So stuff works over here. So your answer is negative infinity to positive infinity. And the graph would be like this. It shows that everything works. You'd color from the left to the right. Right here is when you could make that determination. But some of you are going to make a mistake and just see a negative number and go, oh, it's all real. I mean, it's no solution. I mean, I'm not sure which one it is. Go ahead and go through the solving process. Let's do the last one, then we're done. Change this, please, to positive 2/3 and a negative 1. So again, we're looking at my initial inequality sign says less than, correct? It's an and it's open circles. I want to get my absolute value all by itself, so I'm going to multiply both sides by what? 3 over 2, good. If I multiply this side by 3 over 2, this side by 3 over 2, this is the absolute value of 4x plus 8 is less than negative 3 over 2. Right now, you can tell me what that answer is. No solution. Why is this one no solution?
Because absolute value will never be
Because the absolute value of something will never be less than. But again, guys, that's an easy thing to mess up if you just don't realize that, oh, this one said greater than, this one said less than. So go ahead and finish this problem. You have 4x plus 8 less than negative 3 over 2. 4x plus 8 greater than positive 3 over 2. I'm going to subtract 8 from both sides. What would I make 8 into if I had 2 as a denominator? 16 over 2. So this is minus 16 over 2. So 4x is less than 16 to negative 19 over 2. Now I have to divide by 4. Do you guys agree that I'm dividing by 4 over 1? So if we keep change flip, I have negative 19 over 2 times 1 over 4. I have x is less than negative 19 over 8. Same thing over here. I'm going to subtract 8 from both sides, which I'm really subtracting 16 over 2. So 4x is greater than negative 13 over 2. Divide by 4. I get x is greater than, I have negative 13 over 2 times 1 over 4. So it's going to give me negative 13 over 8. So when we go to graph this, negative 19 over 8, negative 13 over 8, and 0. What kind of dots do I have? Open. And I originally said I was going to color which direction? Inside. Okay, I originally said I was going to go here. What do my inequality signs say? I should go which direction? From negative 19 over 8, which is ways does it say I should go? To the left. From negative 13 over 8, which way does it say I should go? To the right. So this one, you guys could be like, oh, wait, it's all real solutions because it looks like everything's covered. But that's not the case. Up here, when it was all real, everything was covered. Here, it's just like we're confused. We don't know which way we're supposed to shade. When you get to something like this and you're not sure, you didn't catch it up here that it was no solution. This is when we plug in numbers. Plug in a number on a number line that's bigger than negative 13 over 8. 0. Plug in 0. According to how we have it shaded, should 0 work? Yeah, it should work according to how we have it shaded, but let's check. If I plug in 0 here, I have the absolute value of 8. If I multiply the absolute value of a positive number times another positive number, is it ever going to be less than a negative? No. So that doesn't work. Plug in something to the right. Plug in negative 5. Negative 5 times 4 is negative 20. Negative 20 plus 8 is negative 12. But the absolute value of negative 12 is what?
12.
Positive 12. If you multiply positive 12 by a positive number, is it going to be less than a negative? No. What do you think happens when I plug in something right here in the middle? It's not going to work either. If nothing works, guys, what's your answer? No solution. So if you catch it here at this point and write no solution, that's fine. But it's very easily confused with this one. All real and no solution. But if you continue to work it out and you go through the process of checking the inequality signs, checking algebraically what works and what doesn't, you should be able to find your solutions. Questions?